All right, we're rolling. What do we got here? We got 6.3. Okay, so 6.3, we're going to do medians and altitudes of a triangle. And I like this one the most because it has some kind of nice properties we can use with triangles. But they're all pretty good, but this is probably my favorite one. All right, so specifically medians. Don't think we're going to do anything with altitudes. Yeah, so we're going to skip the altitudes and we're just going to focus mainly on medians. All right, so what is a median? All right, median of a triangle is, let's just go to here. Okay, what is a median? It's a segment that connects a midpoint of a triangle and the opposite vertex. So basically you find the vertex, or sorry, you find the midpoint of a side, and then you connect that to the point of the triangle across from it, and that's a median. So if we use a ruler, well, you don't have to use a ruler, but if you use a ruler, draw a nice triangle, it's a lot easier to make it. Oh, I don't want that shape. Let's delete that, and let's do just a regular old segment here. All right. Let's say we have a triangle, and don't make it equilateral because then it's not clear what you're doing. Just make it so it's just, I don't know, anything that's not equilateral so you can see. All right, so what we're going to do is we're going to make a segment that connects the midpoint of a triangle to the opposite vertex. Okay, so, and I guess I should say the midpoint of a side of a triangle. That'd probably be more accurate. I think you know what I mean. So let's say I take a ruler and I find the middle of this side here, which we'll say is right here. Okay, and just to be clear, I'm going to label this as the midpoint. And then what I'm going to do is I'm going to connect that to the vertex or the point opposite of that. So, like so, we have a median. All right, this is my median. All right, so from the median, if I make 3 of them, I get what's called a centroid. And this is where the medians of a triangle cross. Okay, so let's draw another triangle. Let's do 3 medians this time. And if you do it correctly, you don't mess up or go way off from where your point was, you should end up with them crossing at one point. Right now, if your midpoint's not exact, be off by a little bit. That's fine. You know, it can't be perfect, but do your best. So let's draw another triangle here. And just don't make it equilateral because, like, once again, you can do that. It just is less clear what you're doing if it's equilateral. All right, so I'm going to draw a triangle here. Let's do something like this. Yeah, why not? Just make it nice and big so we can see what's going on here. And yeah, make it nice and big because we are going to be labeling the, whatchamacallit. We're going to be labeling the lengths of these in a second here. So make it nice and big so we can do that. All right, so I'm going to do the midpoint of each side. I'm just going to, I don't have a ruler for this smartboard here, so I'm just going to sort of guesstimate. You can do the same. The midpoint of each side. Look about right, yes. All right, and then I'm going to connect them with the opposite vertex of the triangle. So there, there, there-ish. Okay. And we have, I'll put it in blue here. That is my centroid, okay? Blue dot is my centroid. Okay, so pretty simple to draw. Just find the middle, connect to the opposite point. You don't need any right angles. Usually they aren't right angles unless you have a like an equilateral triangle or isosceles or something like that. But yeah, there we go. So what is the centroid theorem? How can we use this? Okay, if you have the centroids, it actually always ends up that one length is double the other for any given median. All right, so how do I want to phrase this? So we'll say this: the two segments of a median, two segments of median created by the centroid All right, so here's what I'm saying. So when we have a centroid, it splits any given median into two smaller segments. Okay, and what is true about those? Segments of a median created by the centroid have a 2-to-1 ratio. Essentially, one is double the other. Okay, I'll give you an example here. Let's say that this length right here was 10. Okay? If that length right there is 10, that would mean that if this is the centroid, this one right here has to be 20. Make sense? Okay, now, what you need to understand is your textbook doesn't phrase it like this. I think this is more useful, but your textbook is going to phrase it, they're going to phrase it as 2/3. Let me explain why, okay? The reason why is you could also say it like this. The median, so this is another way you can say it. The median, so the full median to the centroid to vertex. Okay, let me phrase this. So the ratio of a full median, so the full length and the centroid to a vertex is 2/3. Okay? Or we could say, let me say it like this, 3-2. Or 2/3. All right, so here's how we can use this. Okay, let's use the same triangle up here, and let's call this A, we'll call the middle B, and we'll call this C. All right, if we have this ABC here, let's say that we knew that AC, the length from A to C, equals 27. All right, well, that's a bit tougher to figure out what these lengths are. Now, you can sort of guess and check and say, hey, if I know that this length is double this one, and I need them to add a 27, you can guess and check. But what the textbook is going to do when they show their work is they're going to use this 2/3 ratio, okay? So here's what I mean. We know the full thing is 27, and we know that this right here is 2/3, okay? So they're going to do this. They're going to say, what is 27, or 2/3 of 27, or 27 times 2/3? And if you know your fractions, that should be a piece of cake, but I know fractions are a struggle for everybody. Well, not everybody, but most people. So all you do when you're multiplying a whole number by a fraction is you put this over 1. So you multiply the tops and you divide by the bottom. Okay? So 27 times 2, well, that's 54. So 54 over 3, and 54 divided by 3, well, if you type that in, you get 18, okay? Now, here's where I tell you you don't have to do it this way, because if I know that this is double this, I could sort of guess or check and figure out, all right, this has to be 18 and this has to be 9, okay? So if AC equals 27, then we can say, All right, this is 18, and this is 9. Okay? So once again, the 2/3 thing is helpful to know, but I would say in most cases, the bigger part is double the smaller part. Usually gets to the answer quicker. All right? All right, so that's the centroid theorem. Kind of two ways to go about it, either 2-to-1 or 3-to-2, double or 2/3 ratios. Let's move on. Okay, there's a whole bunch of stuff in here that we don't need to worry about. Okay, so here's where you can use either method, and you'll see why I prefer this double method. All right, so maybe I'll write down this picture here. We got a triangle here, triangle RST, and they got some medians drawn through it. So if you want to pause the video here, draw this, go ahead. All right, so Q is the centroid, which means all of these are medians, and SQ equals 8, which they've labeled in the picture. They want us to find QW and SW, which is the full length here. Okay, so let's first find QW. All right, so remember, the bigger segment is always double the smaller one. Okay, so without doing too much thinking, we can know that QW, if it's a median, has to be what? That double to give us 8, so it's got to be 4. Okay, well, we know that this is 4, and that's 8, and they want to know SW, the full length. Well, the full length has to be 12. Okay, so hopefully you see why I don't usually use the 2/3 unless I'm out of other options. It's just nice to be able to do it quick like this. All right, that's it for that. You'll get some problems like that. Some will be equations you have to solve for x, but essentially they're just like that. All right, we do have to deal with coordinates quite a bit, where you're going to draw the triangle and then you're going to find the centroid by finding the midpoints. Okay? So why don't you either make a graph on your paper or get some graph paper and then graph these points here. Then we're going to connect and make a triangle. All right? I'll do the same. So let's do, and they're all positive numbers, so they're just going to be this top right here, which is why I have it set up like this. So we're going to have point R, which is R 2, 1. All right, so we got point R. We got S, which is 5, 8, 5, 8. And we have T, which is 8, 3. 8, 3, T. And I'm going to connect them. On a problem like this, you really do want to use a ruler. Like I said before, you can get away without using a ruler, but it can throw you off a little bit if your lines aren't straight, because when we're trying to find the midpoint of a line. So I'm going to use my little tool here. You'll want to use a ruler, or like the edge of a folder or something like that. There we go. All right. So let's see here. I just want to make sure I plotted everything correct before I keep going. Yeah, okay, we're good. Okay, so there's more than one way to find the midpoint, right? So if you're finding the midpoint from R to S, right, you could add the x values together and divide by 2. So that's 7 over 2. This is 9 over 2. And you could just as easily find the midpoint that way. Or you can count the spaces. Now, on a problem like this, wait, where am I at? Okay. On a problem like this, there's a 50-50 chance that I'm going to end up with a decimal or a fraction, okay? So don't think you're wrong if you get like something between the lines or you get a fraction or a decimal for your answer. That's totally fine, okay? Because let me show you what happens, okay? If we go from R to S, you could count that it's 3 across, so we got 1.5. And then it's up 7, so we got 3.5. So we end up going over 1.5, up 3.5, and we end up here, okay? Similarly, if we do what we did before, we do midpoint formula. 7 over 2, 9 over 2, that's really 3.5 and 4.5. Decimals are easier to plot on a graph. So in this case, since we're not talking about slope, it does make sense to go ahead and write your midpoint as a decimal. All right, now let's see if we get the same thing. 3.5, 4.5, we end up in the exact same spot. All right, I'll do it in green again so we know which are my midpoints. All right, so go ahead and find the other midpoints. They're not all going to line up perfectly, all right? Just how it is, 50-50 chance, basically. All right, so I get my R to T. So I'll do midpoint formula. So R to T would be 10 over 2. Okay, R to T, and then 3 plus 1 is 4 over 2, which is the same as 5 comma 2. All right, you can count the spaces on your paper as well. So over 6 up 2, so over 3 up 1, and we end up in the same spot. We end up at 5, 2 right there. Okay, last one, and my phone is ringing. Oh my gosh. I think I'll just let it go and then just call him back later. All right, for my last one, we've got S to T. So for S to T, we're going to add them together. 5 plus 8 is 13 over 2. And then 3 plus 8 is 11 over 2. So we're going to end up with fractions again. 13 divided by 2 is 6.5. And 11 divided by 2 is 5.5. And you could count spaces. They're decimals, so it might be faster to do it this way. So 6.5. So I'm here. And then 5.5. I go up 5.5, and I end up right here. Okay. So 2 of them are in between lines and one's on lines. Just depends. All right, let's connect them to make our medians. Boom, and they line up. Center. Now, yours might be off a little bit. Mine was off of the point they're going for quite a, well, not quite a bit, just a tiny bit. But you can kind of see what they're going for. All right? If I did it perfectly, they should cross at this point here, which is, let's look, 5, 4. So my centroid is 5, 4. And I showed you both ways because it doesn't really matter to me how you do it. Okay, some people look at the graph and they just find the middle by counting the spaces and divide by 2. Some people look at the numbers, add them together and divide by 2. Either way is fine. Okay, it doesn't really matter. All right, let's do the next one. Okay, you'll get something like this, and here's what I do. I'd write down this triangle here. You don't need all the pictures or the bushes and benches or whatnot. Just draw the triangle ABC with the medians in it, and then we're going to be asked some questions, okay? All right, so first one. Find PS and PC if SC equals 2100, 2001. So SC, this length right here, they're saying the whole thing is 2100. Okay, just outlining it there. All right, so that's 2100, and we want to find PS and PC. So we can either use the 2/3 rule, or we can use the fact that this is double this. Does not really matter. I'll do the 2/3. Sometimes when you have the full length, it's just as quick to do 2/3. So I'm going to do 2100 times 2/3. All right, 2100 over 1. I get 4200 over 3. And I divide by 4200 by 3, and I get 1400. So that means that this is 1400. In order to add them to 2100, this has to be 700. Okay, so we can say that SP is 700 and PC is 1400. And if you guessed and checked and you got it that way, that works too. All right, let's look at the next one. We're going to say that TC and BC equals 1,000. Find those two, sorry. Find TC and BC when BT equals 1,000. So BT equals 1,000. All right, they're trying to trick us. Okay, this is not a median. This is the side of the triangle, or part of the side of the triangle is 1,000. But when we made a median, right, this is the midpoint. That divides these into equal segments. So we know right away that TC has to be what? It's got to be the same. It's got to be 1,000. So we don't really have to do any math. TC equals 1,000. We just have to know its midpoint. And they want to know BC, the full length. Well, just put them together. 2,000. And I really should label these as feet. Sometimes I get lazy. And these are feet. All right, easy. Let's do this last one here. All right, PA and TA, and we know PT is 800 feet. So they're telling us that this is 800. I'm just going to erase this so I have room. They're saying that this is 800, this right here. And they want to know this length here and the full thing. Okay, use our 2-to-1 rule or double rule. If this is 800, this has AP has to be, or they say PA, same thing. PA has to be 1600 feet. And TA, the full length, we can put them together, has to be 800 and 1600, 2,400 feet. All right, bingo. So not too crazy. You'll get some questions like that. They might give you like a word problem, but usually the word problems even are pretty easy as well for this stuff. Okay. So we are going to find the coordinates of the centroid of these given triangles. Why don't you pause the video here and try to find the centroid? I think, let me just double check here. Yeah, both of these, your centroid will not have a decimal. It'll be a whole number, but you might get some decimals along the way. That's kind of expected, but these ones do work out where the centroid is a whole number, okay? So why don't you graph these on some graph paper, see what the centroid is, and we'll see if we agree. And I'll do both these as well. All right, so I got F is 2, 5. We got G, which is 4, 9. And we got H, which is 6, 1. And I'll connect them. Put on my midpoints. And I get my first centroid right there. So my first centroid is 4, 5. Wait, is that the same one we did before? I feel like that's familiar. I think I'm getting deja vu. Where was that? No, it's 5, 4. It wasn't the same. Okay. All right. Different. All right. Do this one now. Scroll down a little bit. Negative 3, 3. 1, 5. And negative 1, negative 2. And it's X, Y, Z. All right, my midpoints on here. Okay, this is where I'm going to get some decimals, just looking at it. So I'm just going to double check with midpoint formula, okay? So if I do the midpoint, and I'll actually label this time, so mid of xy. Okay, that's going to be negative 3 and 1 is negative 2 over 2 and 8 over 2. Okay, so that's just going to be negative 1, 4. Plot that on there, make sure it matches up. Negative 1, 4. Good, so that one gives me a whole number. Let's do the midpoint. I'll do YZ. All right, negative 1, 1 is 0, so 0 over 2, 3 over 2, so I get 0 and 1.5. I'll plot that, 0, 1.5, right there. And then midpoint, last one is from x to z. All right, -3 and 1 is -4, so -4 over 2. 3 and -2 is 1, 1 over 2, which gives me -2 and 0.5, or a half. -2, 0.5. Right there. My line was off a little bit. If I just adjust that. There we go. Okay. That's why it's important to check with midpoint formula. Your drawing is not going to be perfect. All right, connect them. And we have our centroid right here. So where's our centroid? It is -1 and 2. Okay. So that's finding centroids. Medians and centroids. Now, there is some other stuff in the textbook I need to talk about. The altitude. The altitude is just the perpendicular from a vertex to the other side. And it can be outside the triangle. You don't need to write this down because we are actually not going to do anything with the altitude. But I'll just tell you that that's what the altitude is if they talk about it. We're not going to do anything with it. The orthocenter is where they meet. The properties of the orthocenter are not as useful as the other ones. So we're not really going to do anything with it, just for sake of time. I'll show you one other thing here. Where was that? Okay, this. All right, this here lays out all the centers of a triangle, okay? And the properties, okay? So we had perpendicular bisectors make the circumcenter, which is equidistant from the vertices. Angle bisector makes the incenter, which is equidistant from the sides. Centroid has the 2/3 distance from the midpoint, so it has that ratio we can use to figure out the lengths. Really just double, it's more useful. And then the altitude, they're concurrent at the orthocenter. We don't need to worry about that. Like I said, this last one we're basically just going to skip, okay? The first three are a lot more important, a lot more useful. Okay, that is it. Have a good day. Bye-bye.